Hello guys. Oh, that is extremely loud. Hello guys, welcome back. Sorry about that. There's some lights out in my area, so I couldn't connect to the internet until I tried my hotspot. Sorry about that. After a few attempts, now I'm back online. So let me just share my screen with you, and we'll get back to what we were up to. Why don't I show you what I'm working on, what I'm doing? Oh, you can hear the click of the mouse. That is so cool. Okay, so let me share that with you. You guys won't be able to see it because that screen is off now, right? What do we turn on? I think I should turn this on. Nope. Okay, now you can see this much better. Very good. Okay, of course you'll be able to look at the screen, and I'll also be able to look at your chats from here, so don't worry. But what we are going to do is first go to YouTube Studio and then delete the live videos that didn't last more than a few seconds. So go to content and then I go to live, and here you can see there were two live videos that are less than 2 minutes, which we don't need. No one is going to watch any of them. They're all blurry anyway, so I'm going to delete these two videos. 1 minute and 29 seconds, and yeah, this and that, and we're going to work with this. Oh yeah, you guys are looking at that, aren't you? Okay, back to this. Okay, will it show me a loop if I keep my mouse here? I'm gonna see what it shows. It shows me a loop, doesn't it? Oh, okay, so it's a loop inside a loop of a loop. Nice. Right. Okay, yeah, that's enough looking at it. Continue. Yeah, the videos will be deleted when they are deleted. I'll resize this. I can read the comments and edit OBS over here. Let's get back to this. If you guys would like some music, I can play some music. Why don't I play some music for you guys? So some lo-fi chill. NCS is the word for this, no copyright sounds. I don't need that. So instead of this construction sound, maybe you guys can enjoy some good music. Okay, running music, love song, nostalgia, albums, years, genres. Yes, best of house, best of trap, best of future house. I think future house. Let's find out what future house looks like.
Don't forget about me and all the things I could give to you, baby. But I guess you can't see, making new memories with me. Oh, yeah, I'll be okay. I'll be okay. I'll be okay. Oh, yeah, I'm good either way. I'm good either way. What happened to forever? Now we're not together. I know it's time you probably need a break to see if you were done whatever. Bad and dedicated.
I read that license and apparently I realized I can't do that. So sorry about that. We'll have to make do with this then. Okay. Better. Interesting. Okay. Back to you. We're trying to figure this out, right? If it is, so I think if we remove this, it will pretty much add all the numbers. Oh. Q by. Oh. Command Z. Huh. Command Z, command Z, command Z, command Z. And comment this. Yeah. So when we did this, what did it do? Now we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15. So this is the actual thing that will push. Basically, right. Why are they global variables? Now I'm very interested in understanding why they are global variables. Let me zoom in. That is so much better. Okay. Yeah, zoom in please. Thank you. Oh, lights are in again, but I like this way of setting. What is it? 18 minutes already. Okay, sorry about that, guys. Yeah, okay. Why can't we let primes be an empty array? We can. Okay. Why are you using global variables? Interesting. I'm not going to use global variables anymore. Yeah. Okay. Interesting. Why? We don't need that. I see. That is good spacing. Very good. Okay. So back to this. I'll give you some space again. Okay. That's where it ends. I don't mind. Interesting. Oh. I see. First of all, I will solve this space problem. Now all of them. Very good. 4 spaces. I didn't even require 4 spaces. Why is tab 4 spaces? Must have written in the comments settings. Wait, it should be here. Tab. How does this not have those settings? Campfire. It did. Interesting. That went away. Nope. Off. No. Email, internet. Interesting. That went away. No. Fine. So tab is somehow 4 spaces now. Why? We'll never know. Cool. Back to this. Now let's try to understand why and what this is. छोड़ना चलेगा. Okay, so there is a for loop, and inside a for loop there is another for loop, but it's an if statement, and if statement does two things. So now we have 2, 3, 5, 7. So this is the thing that filters the values, right? So for the first iteration it added the number 2, right? So then we have another loop. Let j equals I. Have to read what this does again. It says the operator shifts the left operand left by 1 bit after converting. It's just a quick way to multiply by 2. So I multiplied by 2. So 2 multiplied by 2, 4. Oh. But it says 1 here. The inner loop sees j to true for all multiples of I. Reason for doing that that no multiple of I can be prime. Yes. Oh, so this is the multiple thing. I still don't understand this. Let j equals whatever the value of I is for each iteration. So right now it's 2. So 2 divided by 1. Let's Google this. Maybe this. When was this code written, by the way? It was written in 2012. We've come a long way. I'm sure we'll find this. JavaScript. Left shift. Very good. Left shift operator returns a number of or big integer whose binary representation is the first operand. Okay. Right, so we have constant a, constant b, 5 and 2. If we write console.log a, this is by b. I've been using a big screen, aren't I? Okay, so binary representation. So the binary representation of number 5 is this, and the binary representation of number 2 is this. Okay, excess bits shifted off to the left are discarded and 0 bits are shifted in from the right. I can see, maybe zoom better. So what does this do? 5 and 2, a left shift. So a and b, it shifts 5 values to the left of b. So 101 moves 2 of this b. So 101. So expected output is 20. 5 and 2. When we use left shift, it returns 20. What is the correlation? 101. Here it's 101. There is 101 here too, but this is 10. Oh, okay. Interesting. Oh, but that's something else, really. That's something else. That's that's CCSS. This operator is overloaded for two types of operands, number and big integer. For numbers, the operator returns a 32-bit integer. For numbers, for big integers, the operator returns a big int. It first coerces both operands to numeric values. To numeric values and test the types of them. It performs a big int left shift if both operands become big ints. Otherwise, now what is a big integer? Big int values represent numeric values too large to be represented by the number primitive. So this, can we say, yeah, n is a big int, right? That's a huge string. We have ff, then say big int. Okay, right. So too large to be represented. Okay. Number and big int. For numbers, there are 32-bit integers. So this must be 32 bits. 10 10 10 10 10. For big ints, nope. Where does this sentence end? Yeah. It first course, nope. It performs big, nope. It converts both operands to 32-bit integers and performs number left shift. Shift. We used shift somewhere, I think. Is that? No, I don't think. So you shifted this to the left. Shift B to A. Huh? But this, I can see 101 is over here. Wow. You guys can hear that. Amazing. You guys can hear that. Oh, hello, we have 2 viewers chiming. Hello. Do we have any comments? Nope. Okay. Back to this. So it shifts B to A. So it shifted this because there 2 bits. It shifted this by 2 bits. We don't see 1 0 here, or maybe we do. I have no clue. What does this return? It returns 20. Why? Maybe because the value of 20 is this. Let's think. This is 1, then 2, and then 3, and then 4, and then 5, and then 6, and then 7, and then 8, 9, 10, then 11. How is this 20? I have to understand binary again. Okay. It converts both operands to 32-bit and performs number left shift. A type error is thrown if one operand becomes a big integer again. The operator operates on the left operand's bit representation. Left operand's bit representation. So left operand के bit representation पे करता है. Okay, क्या करता है? So we have 9 base 10, right? So this is what 9's value is. That's what 9 looks like. And then 9 this. So now it moved this by 2. Bitwise 32 integer x to the left by y bits yields x multiplied by 2. For example, 9 is equivalent to 9 multiplied by 2, 3 equals 9 by 8. Huh? Oh, it's 2 raised to 3, not 2 multiplied by, right? So 9 multiplied with 2 raised to 3. If we write this, So is it always 2 raised to 3, is it ever 3 raised to 3? Unsigned. Do not use to truncate numbers to integers, math.trunc instead. Right, so this returns 72. So 9 multiplied by 2 raised to 3 is 72. So 72n. Maybe, okay, now maybe I get it. So this means I, which is 2 multiplied by 2 raised to 1. So 2 square, or the multiple of 2. Right. But how do we know that with each iteration it will still be 2? Let's say 3 multiplied by 2 raised to 1. Will it be 3 multiplied by 2 raised to 1? That is what we have to know. So we know 2, 3, 5, 7 works. Let's take 4 for example. So 4, so we'll let the value of j be 4 multiplied by 2 raised to 1. So 4 to 8, right? So now 8 is the value of j. Now it will check whether sieve j is true. Wait, no. Yes, it will. No, it won't check. It will set the value of sieve, which is the 8th value, but this is invalid to be true. What if we write ha 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 ha? Right, nothing happens. Why does nothing happen? Why does this remove? No, that itself doesn't remove it, the for iteration does. But why? Maybe let's read the entire loop again. So the loop begins from this. We declare a variable called I, and we assign it the value of 2. Very good. And we wanted to run till 10, 977. Cool. ठीक है. So 977 तक ये करेगा. ठीक है. Oh, not 977 तक. It will do it till 977 times. It will do it 977 times. Fine. We'll get there. I plus plus. If sieve I undefined किया. So if something is true, you do this. If it is not true, don't do anything really. Simply return primes. So sir, इसके अंदर सब लोचा है. अभी what are we pushing? So primes dot push I. So basically with each iteration we'll add it. Yeah, so 2, 3, 4, 5, 6. So I understood that. If I comment this part, if I comment this part, we will have 2, 3, 4, 5, 6, 7 until whatever the number is, right? Now we come back to this for loop. What does this for loop do? So let j, so it declares a variable called j and assigns it the value this. Well, assigns it this value. Now what does this value do or mean? So what we read in left shift, basically I is multiplied with a number with base 1. But what number is that? Well, not base, power. A number with power 1. I have no clue what the base is yet. Maybe if I read this. For two types of operand. For numbers, the operator returns 32-bit integer. Will the base always be 2? this is something else. For example, 100 is the same as and produces 100 because 32 modulo. Yeah, okay. Left shifting number x by 0 returns x. Do not use to truncate numbers to integers. Right. I still don't get it. Yeah, but we can do this. Primes. Seven, 3, 1, 5, 6. Interestingly, that worked. But again, I have no clue. What value do you assign it? Let's say you gave it a value, right? You gave it 72, 1, 2, 3, 4, whatever. But C remains empty all its life. So, what are you doing by assigning it a value? I see. I think you're playing it with playing the second number. So right now, let's think of the first iteration. The first iteration is where the value of I is 2. If C's second value with the second Sieve arrays index value 2 is not undefined, logically not, whatever that means, but this somehow returns true. I think they're trying to say that something doesn't exist. See if I doesn't exist or undefined. So if this doesn't exist, then you do this, right? So if it doesn't exist, then you do this. Cool. Now it runs a for loop inside this. Yeah, I have to understand. You know what? I can do that then. Sub को comment कर. No. Instead you can write console.log. क्या लिखा था उन्होंने सबसे पहले? Right. This returns 20 because 5 multiplied by what returns 20? 4, which is 2 squared. What if I make this 3? So 5 multiplied by 8. So apparently the base stays 2. That's good news. So you're multiplying every number with 2. 5 multiplied by 2 raised to 3, which is 8. 2 raised to 3 is 8, and 8 5 is 40. Right. Command Z. I want to try something else. Let's check the first iteration. 2 multiplied by 1. It would return 4. So let J be 4. If J is less than number, which is 97, then you change value of J from J to J equals J plus I for the next iteration. अच्छा इसके अंदर भी ये मस्त अच्छा I get it. पहले वो 2 को पुश कर देगा, पहले उसने प्राइम्स में 2 को पुश कर दिया, अभी 2 के सारे मल्टीपल्स को ढूंढेगा। Nice. What does this return? We never printed the value of sieve. सारी ट्रू वैल्यूज उसमें पुश होती जा रही है। Right. Okay, now I get it. So 2 into 2, which is 4. Then j becomes 4. Because j equals j plus I, so 4 plus 2 is 6, so it will go through each multiple of 2, because a multiple of a number can never be a prime, so वो हर एक multiple को वो एक value देगा क्या, so sieve number 4 is true, so that's why you see 1 2 3 4, the first 4 values are empty, because 0 1 2 3 and 4th, with the 4th value it becomes true, so you're literally making it true. Wow, wow, clever. Yeah, then we go to the next iteration of this number itself, 2 4 6 8 7 8 9, yeah, till all multiple, wait, not all multiples until a specified number, sorry, yeah, it would become an infinite loop, right? So the moment, so after you're done, the loop starts again, and then it checks for, now the value of 2i is 3, now it will push 3. Now I can try to understand what this is. So sieve, yeah, with this iteration we already have an array now, so it's a full array, right? So see, if sieve I, which is 3, if the third value 0 1 2 and 3, if the sieve I, what do you return? It's not, yeah, if sieve I and then this, what does that mean? Logical not operator. If it's not 3, no, it's empty, this value is empty. If sieve I is empty, not empty, but it's not empty, wait, if it's not undefined, it is defined. I have no clue what they've written here, what this means, but I understand sieve I, for the second iteration the value of I will be 3, so sieve I returns what? Let's find out. Okay, sieve 3, it returns undefined, and what do we write? This, then it returns true. Yeah, why? Why does it return true and not anything else? Is it simply supposed to be true for every statement? Okay, let's try 4 then. 4 is false. Acha. And it says true. So yeah, this returns the opposite of what it is. So the opposite of undefined is false somehow. Acha. I have to dig deeper. So okay, if we print the sieve, I think this live won't last long. I've already finished 2 GB of my data. I'm fast approaching the end, but we'll try to be online as much as possible, don't worry guys. Right, so return sieve. This is this. So when it returns the fourth thing's value and we want it to return opposite, so it will do nothing. So I think they're ensuring, what are they ensuring? That you don't get multiples of each number, because after 3 it will be different, won't it? Oh yeah, so with this, think of this as 3 now. Yeah, think of this as 3 now. In the third iteration, 2 and then 3 are already a part of primes. Then it goes through that. Now it will iterate through each multiple. How? So I is 3, so 3 multiplied by 2 is 6, then 6 is 6 plus 2, 8. Why would 8 be a part of this? Sorry, 6 plus 3, yeah, multiples of 3, sorry, yeah. And it will give the jth value, or not the jth value, the jth value really, the jth value true. It will assign that operator. So jth value for the first iteration of 3 would be, well, after 3 would be 0, 1, 2, 3, 4, 5, 6. So 6 is true. Well, 2 and 3 both are factors of 6, so I can understand it can be true for, yeah, it could have been overwritten, but I get it. This way we think, with this we also avoid all the multiples, iterating through all the multiples. So sieve, this sieve array turns out to be a guide. But dude, if sieve I is false, then don't do anything. Don't add it, don't push it. Literally don't push it. Okay. And we are good to go. 62% complete, guys. Very good. I love this. Very nice. Just a second, let me adjust my mouse. Okay. Sorry about that. It is extremely noisy, I just realized. Sorry about that, guys. So smallest common multiple, LCM, as one would like to call lowest common multiple or the smallest common multiple, right? Find the smallest common multiple of the provided parameters that can be evenly divided by both as well as by all sequential numbers in the range between these parameters. It will only take two arguments. Very good. We are going to use the arguments object again, right? The range will be an array of two numbers that will not necessarily be in numerical order. We'll sort them. For example, if given 1 and 3, then find the smallest common multiple of both 1 and 3 that is also evenly divisible by all numbers between 1 and 3. The answer would be 6. So when I write 1 and 3, I want to find out the LCM of 1, 2 and 3. Is that right? So we have 1, 2, 5, right? 1 and 5. So 1, of course, it's multiple, each multiple, every number is a multiple of 1 really. Then we go to 2. Multiple of 2 and 5 is, of course, 10. Then 3 and 5, 15, but that wouldn't work well with 2. So I think there is a better way of doing this. Prime factorization. But yeah, okay, let's use our brain. 4 will work with any multiples of 2, really. All we have to think of is 30. 330, but that won't work with 4. 60 should do it. Yep. Oh, that's I could have just read that. Right. There should be a trick then. How do you logically write it? Their multiples meet somewhere. Like 2 and 10 says 2520, 1 and 13 says 2 and whatever. Right. Think. What's the logic behind this? First we have to print them, of course. 2, 3 and 4. So we can create an array. So the first thing we can do is create an array. So let new arr be an empty array. New array be an empty array, then we write a for loop. I have become very fond of for loops, haven't I? Okay. Arguments Yeah, right. I shouldn't have written the arguments object. Run this loop 5 times. Why does this? Oh yeah, because this is not new array. Okay. Why are we pushing it? Zero and then 1 and then 2 and then 3 and then 4. Why? Why are you not doing that? Interesting. Oh. Because this is an array, right? It's not an argument. Oh, come on. Think, man. Come on. Obviously. I don't even need to write that. Oh, actually I do. Yeah. How about we then also need to write a sorting function. Dot sort item. Actually no. A comma B arrow function minus b. Right, so even if we write 5 and 1, we'll still return 1 2 3 4. Oh, and the number itself, right? Equals. So that's kind of sorts it out. Wow, I was mesmerized. Okay, back to you. So now we have an array with each number, right? If we write 2 to 10, it will get us that number, 2 to 10. Oh, right. Yeah, 0. Okay, done. Well, not done really, we have to return. Yeah, we're going to use reduce to find an LCM. Find LCM of a number of numbers in Java. So what does this say? Variable called LCM, which is a function n1 and 2 find the GC. Okay, greatest common divisor. Then calculate the LCM. Right. Okay. Let's read this. Why did I even scroll? Why? Okay, when we write 15, 20, 5 and 7. So LCM of 15 and 20 will return 60 and 5 and 7 will return 35. Okay, with using GCD. Interesting. With using GCD, I could have simply written with GCD. Okay, so the mathematical formula says number 1 and number 2 divided by GCD n1 and n2, right? Let's read this then. This is a function LCM. This is an anonymous function which takes n1 and n2. So it takes two arguments from an array. Yeah, two arguments from an array. And then what does it do? It declares an variable that is also interesting. Declares another function inside, so a callback function, and that what? Oh, okay. Time complexity is this, space complexity is this. We're finding the GCD of the given number. Okay, I don't trust this website, sorry. Program is, where is it? W3. That's W3 resource. Tutorials point, Geeks for Geeks. Geeks for Geeks is actually trusted. I like how they explain things. It has an ad by W3 resource. This is a website built by someone. Creative Commons W3 resource, right? This has not been placed correctly, or maybe it is. This must be for ads. Okay, JavaScript and math exercise 10 with solution. LCM 2 numbers. HTML code looks like this, JavaScript code looks like this. Right, there is a function LCM of two numbers. Type of x is strictly not equal to a number type of y is strictly not equal to a number, then return false. Otherwise return not x or not y. It should simply return true. If that were true, oh god, I have to really understand this logical not operator. Math.abs abstract, nope. Right, I still don't get the logic here. So, okay, maybe we can use their hints. The smallest common okay, that's a problem explanation. You can use remainder operator to check if the remainder of a division is 0, which means it is evenly divisible. Okay, why? Okay, the smallest common multiple between two numbers is the smallest number that numbers can divide into evenly. This concept can be extended to more than two numbers as well. We can first start with finding the smallest common multiple between two numbers. Naively, we can start writing out multiple of each number until we write a multiple that exists from both numbers. Naively, ना सीखिए, हमें पता नहीं, naively, okay. Anyway, an example would be numbers 3 and 4. The multiple of 3 are 3, 6, 9, 12, whatever, and multiples of 4. The first smallest number we run into both lists as well, so this is the smallest common multiple. And faster, oh god. A faster approach is to check all multiples of 4 to see if they are also multiples of 3 by checking the remainder when we divide the multiple of 4 by 3. Right. Be careful. Do not forget the keyword range. If we are given 1, 5, then we have to check for the SCM for all the numbers 1, 2, 3, 4, 5, which is the smallest number that is evenly divisible by all of them. We have to find out LCM. Someone must have written, okay, this is a Wikipedia page for LCM. Back to you. And GCD, right, so we have to use GCD. Have to. The greatest common denominator. It's not divisor. As synonymous with greatest. Oh, it is synonymous with greatest common divisor. This contradicts the common meaning of the words that are used in our reference to fractions. Two fractions do not have any greatest common denominator. If two fractions have the same denominator, one obtains a greater common denominator by multiplying all numerators and denominators by the same integer. Right. In math, the greatest of two or more integers which are not all 0 is the largest positive integer that divides each of the integers. Least common multiple, greatest common divisor, right? So let's take 2 and 5, 1, maybe a better example, 2 and 10, maybe another one, 5 and 20, 4. No, 4 doesn't divide 5. God. 5 itself. Okay, example पढ़ते हैं. For example, GCD of 8 and 12 is 4. That is GCD 8, 12, 4. The way they wrote this, can we do that with JavaScript? GCD data infinity is W3. What is the function GCD? Why does W3 schools not have it? Why do we need GCD, by the way? Yeah, I'll use that. Let's read the title of solution. So looping, ES6 looping basically you use ES6 methods, GCD and LCM, prime factorization. I am interested in prime factorization. Right, long. Yeah, I think they're all long. Take your pick. I'm going to take looping approach. Constant, minimum, maximum, sorted. So you sort the list. Cool. Next, number divisions is max minus min plus 1. Divisors. Right, so 5 minus 1 is 4, for example. So this stores 5. Max minus minimum plus 1. Largest possible value for SEM. Right, so you set it up and then you now find the largest possible value for common multiple. Okay, least common, smallest common multiple. Right, let upper bound equals 1. Right, then you will create a for loop. For loop runs till the max value. So I equals a minimum. I think something like what we are doing, but it's instead of pushing it, it changes, multiplies it. So multiples of all the numbers from the beginning. I get it, kind of get it. This won't be push anymore. Plus, no, multiplies equals, what did it say? I. Right. Right. So it does that now. Let's keep this short. 5, 120. That's factorial. Not factorial, it will multiply. Let 2 and then I will become I plus plus, so 2 will become 3 and then 4. Right, but when does it stop? Thrice. अच्छा, I की वैल्यू जब 1 अच्छा 2 है तो क्या करेगा? न्यू अरे इक्वल्स न्यू अरे इनटू I. So now with first iteration this has become 2, then 3 को मल्टीप्लाई करेगा 2 के साथ 6. Oh, is that 8? No way. Nope, it cannot be. Exactly. Exactly. 1 to 5 returns, also returns 120. What if I write 3 to 5? Right, we don't want that. Okay, basically after this loop it becomes 120. So you're multiplying 1 and 2 and 3 and 4 and 5. So basically this is factorial. Right, 3, 2. So 4 and 3 and 2. Not factorial really. Multiply all the numbers between these numbers. Cool. Right. And themselves too. Cool. फिर क्या? Largest possible value for. Are you going to divide them all or what? Test all multiples of max. Multiples of max. Right. Okay guys, just a second. I can see it's 1:50. I'm going to take a short break now. When I'm back, we will continue with this LCM thing. Until then, I will see you guys back again. Thank you. Thank you, and thank you for watching the live video. Have a good day.